And on the other side, there is a kind of instruction you cannot really do inside the CPU because you don't have the space to engrave everything, and you will have a coprocessor there, and here enter, for example, the graphical card that are for Nvidia. That's it?
That's correct, yes. And because if you want to do a specific computation for in such a matrix computation, it's either you do it by CPU. So in this case, you have all the partition of the matrix computation. You need to do some sum, multiplication, etc. It's going to cost you multiple cycles to do it. Or if you want to do it in one cycle, you need to develop or write a specific hardware to do the matrix computation. So hardware means extra square millimeters in terms of silicon production. So it means extra cost. And if you want to afford this extra cost in your chip, in this case, you must use it. If not, you just carry some spare square millimeters on the chip. You pay it for nothing. So if you develop it, you need to use it.
So basically, the matrix of silicon is the square millimeter cycle, the way you engrave stuff on this, and a good product is a product which use easily every part of the square millimeter, because in a perfect world we can figure out a very big stuff with every operation engraved inside, and it will be simple. But what you say, it will be so expensive that it will never be affordable and will be sustainable for a company to buy it, isn't it?
That's absolutely correct. At the end, it's a product. You need to produce this product, so you have a cost per square millimeter, small chip, big chip. Ideally, everything has to be used. If not, you just carry some dead bodies on the chip and some square meters you will not use. And the more powerful is the chip, and that's what happens now. They are, let's say, larger and larger with more instructions, more computing capacity, and of course, much more power, which is used to manage them.
Okay, so that's the point of view of what is a chip. So Cypern is more focused on the CPU.